Okay, for volumes example 2, we kind of want to take a look at what voxel resolution is and what a voxel is. So let's start off by taking a sphere here, and let's create a volume for that. We can use the ISO offset sub that will simply turn our surface here into a volume. It's a fog volume, and I give it a uniform sampling here to 10. Uniform sampling divisions to 10. This means that it will give a voxel resolution of 10 by 10 by 10. Since we now have to think three-dimensionally, so it gets 10 voxels in X, 10 voxels in Y, and 10 voxels in Z. This results in a voxel resolution of 10 times 10 times 10, which is 1000. So if you scroll wheel click on the ISO offset here, you can see that under volume resolution, it says that volume 0 is 10 by 10 by 10, and the voxel count is 1000. We also want to name this to density, just to keep it consistent. So you can now see that the volume 0 is density, and it's 10 by 10 by 10, and the voxel count is 1000. I've now done the same thing here in another volume, in another ISO offset, for the same surface. This volume is, I'm going to also call it density. But this volume, instead of giving 10 sampling divisions, I'm going to give it 50. That means that this resolution is much higher. So the density, volume resolution 0 density, is 50 by 48 by 50. So that means it has 50, it has 50 voxels in X, 50 voxels in Y, and 50 voxels in Z. And the total voxel count is 120,000 voxels, which is quite a difference. So if you do a switch here, we can actually switch between them and see what happens. We can see that the resolution on the right, on the number 1 input, is a lot higher. So this is something we always want to keep in mind. Like, we want to keep our voxels to a pretty high resolution to get good looking smoke simulations or fire or whatever. But we also want to keep it in mind that we can't go too crazy, because it's going to take a lot of space. It's going to get overall very heavy and slow. So that is basically voxels and kind of how this resolution works. You can always middle mouse click on a volume and see this kind of volume resolution to kind of determine where you are at with your resolution and where you're going. So yeah, that's example 2. Thank you.